Hey guys, it's Michael with Breaking Concepts, and today we're going to look at a quick questions about breeding rabbit. Now, this actually is riding on our last video where we've learned about recursive sequence and Fibonacci sequence. So here's the question. I've taken it from the textbook, and try and pause this video and try it out yourself first. So let's look at this question together. So suppose the rabbit lives forever and that every month each pair produces a new pair, and which becomes reproductive at the age of 2 months. Now, if we start with one newborn pair, how many pairs of rabbits will we have in the nth month? Show that the answer is Fn, and the nth term is the Fibonacci sequence defined in example 4, but I've put it down here. Okay, so this question, let's start with drawing a diagram and understand kind of what's going on. So if we draw so let's do 5 months. M1, month 1, month 2, month 3, month 4, and month 5. So the question gave us that in the first month, there will be one pair. So we draw one pair, but that pair is a newborn pair, right? So if you start with one newborn pair, right? So we know that we have to wait for 2 months in order for that pair to be reproductive. So month 1, they're not reproductive. Month 2, they're not reproductive. And in month 3, they will become reproductive. So what that means is, number 1, we will have our original pair. So our original pair is, I'm going to use the blue, continue. And we're going to have a new pair. And for new pair, I'm going to use a green. Okay? Because they're reproductive after 2 months. And so we can see that we actually have a total of two pairs in month 3, and in month 1 and 2 we have 1 respectively. And so moving to month 4, we know that the same pair of rabbit, the old one, right, it's going to say it's going to be here because they live forever, and our new rabbit's pair is also going to be here, right, from our previous month. But one extra thing to not forget is that, remember, it says that every month each pair produces a new pair, which means that this pair, right, this pair will also produce in month 4, which means that we will have a new pair that I'll use for this one. And just to make it more obvious, you can see that, okay, these two come from this one, the blue one, the blue pair. So now, in total, we actually have 3 pair in month 4. And so moving on to month 5, what we're going to have is the same thing. We have our very original OG pair, right? And then we have the pair from M4 for month 4. And again, the rabbit will reproduce every month. And so we're going to have to add an extra, let's say, a pink one. And this pink one also comes from the OG one. Okay, so we have 1, 2, 3. And now look at the green one, the green pairs. For the green pairs, we know that it's after 2 months, so they themselves would also reproduce. So I'm going to use another color. Maybe I'll use the purple. Purple. And so we know that we have 1, 2 from the green pair, and we have a total of actually 3 from the OG pair. So 3 plus 2 is 5. We know that for month 5, we have a total of 5 pair. So now looking at the numbers, 1, 1, 2, 3, 5, this is actually a Fibonacci sequence. And now we can write some formula to kind of show that it is the same as the Fibonacci sequence. So looking at here, we have Fn minus 2. What is Fn minus 2? So we have to define where n is first. So let's define n as number 3 here. And the reason being, we have to remember there's a condition within a Fibonacci sequence is that the n must be greater than or equals to 3. And so for our n minus 2, it's just going to be our n3 minus 2, and that's 3 minus 2, that's 1. So that's F1. F1 is month 1. And what do we have in F1? Just 1, right? So we only have 1. And the same thing for Fn minus 1, it's F2. And F2, we only have 1. And so for the newer month, right, for the nth month, what we have is F3. F3 is equals to, we can start using the Fibonacci sequence, is equals to our F2 plus our F1, and hence we have 2. And then F4 is equals to F3 plus F2. So we know that F3 is 2 and F2 is 1, so 2 plus 1 is 3. F5, same thing as F4 plus F3. So F4 plus F3, we have 3 here, 2 here, is 3 plus 2 is equals to 5, which is basically our Fibonacci sequence, and that's how we do it. So when I was solving this question, I understand the diagram portion. It makes total sense to me. What it might not click with me instantly is how does this logically make sense? I mean, we have the word problem here, and suddenly we have the Fibonacci sequence. I was asking myself if this is just a tried and true method, or there's actually some reasoning behind that. And as a matter of fact, there is a reason behind that. So let's look at the 2 points that I've mentioned. Here's the reason why the solution for this question is Fn equals to Fn minus 1 plus Fn minus 2. So Fn minus 1 itself, if you look at the first point here, number 1, it says the rabbits live forever, which is a given fact, and every single pair in the previous month will still be alive in month n, which makes total sense. Imagine you have 8 rabbits from last month, and assuming that they are not going to die, and they live forever, in this month, there are still going to be 8 rabbits at least, because that is transferable. So Fn minus 1 represents the existing pair. For point number 2, we saw that every mature pair would produce exactly 1 new pair, right? Rabbits are productive at the age of 2 months. And any rabbits that was already alive at 2 months. So what this means is, as long as they are, after 2 months, they can start reproducing, and they will reproduce every single month from then on. And so any rabbits that has already been alive for more than 2 months, they will reproduce. So Fn minus 2 represents the newly born population. So therefore, we have Fn. The formula is basically Fn is equals to existing pairs plus the newborn pairs. So a quick question for you. Aren't we double counting when we add the n minus 2 to n minus 1? Because, like you said, in n minus 1, we already have a population. In n minus 2, we already have that single population too. Like we have 8 rabbits in n minus 2. We also have 8 rabbits in n minus 1. And we're adding them together. Are we double counting this? Becomes like 16 or at least 16 or whatever? That's the idea. The reason why we're double counting this is because for n minus 2, we're not adding the population as a whole. We're adding the population of the newborn because one pair will produce another pair. So n minus 1 have already added and taken into account this pair, and we want to use n minus 2 to take account of a newborn pair. And so there is no conflict, and this is the right solution. So thank you so very much for watching, and here's the solution. In the next video, we're going to talk about discrete time models.